All right, so exam two, right? We are heading into spring break right now, and so next week we won't be having any classes, but the homework is going to be staying open, and you'll be able to work on the homework as well as the quizzes up until Monday the 11th. So you have some time still to work on it, and then the test is on the 12th and 13th specifically, but if you do need to take it earlier, you can. It is open on the 11th as well. So you could take it the 11th, 12th, or 13th in the testing center. If you don't have things set up for you, getting registered for that exam, make sure that you do that right away so you can get the time that you would like for that. And so this is exam two, so it's going to be covering modules 4 and module 5, and so a lot of that is dealing with factoring, and so we will spend some time today talking about factoring quite a bit, because if you are struggling with factoring at all, this test is going to be pretty tricky to get through. So understanding how to do factoring will help you the most on this exam. Okay. All right. So let's see here. Yeah. So let's see. So I'm just making sure I'm looking at some of the questions here in the chat. So there were some questions that we'll look at here in just a little bit. So yeah, we'll review over module 4 and module 5. Both of those are what will be on the exam. Okay. All right, so let's start off. Just 1 second. A minute here. For some reason, my pad that I write on is not responding, so I'm just trying to make sure that, okay, here we go. All right, and I'm guessing everybody can see what we have here on the screen. So first off, I just wanted to talk a little bit about how you can kind of tell what type of factoring you're supposed to be doing when. So if you are given two terms, usually you'll be looking for doing a difference of squares or a difference or sum of cubes. I mean, not always, but that's typically, if you have two terms, that's what you're looking for. And when we do some of those, I'll explain how you can see those. And then if there's three terms, then we'll talk about a few different ways that we can do it. If you guys watched my video that I posted in the announcements about factoring, I showed ways to do the factoring trinomials by grouping, the box method, and then also something called synthetic factoring. And I want you to keep in mind that you do not have to do it in these methods. If you've learned another method in another class that that makes more sense to you, there's so many different ways that you can factor. I just want you to get comfortable with a way to factor these trinomials. There's so many ways to do that. Okay, so I don't want you to think like, oh, if you don't do it the way, one of the ways I, explained, then you're doing it wrong. No, that is not the case at all. Okay, I do want to make sure that's clear. And then if there are usually 4 terms, that's when you'll be doing that factor by grouping. Okay, and also make sure you notice here that I said, the first thing that we always want to do is look to factor out the greatest common factor. Okay, so we start there, then we figure out what kind of factoring we're going to do, and then you can always check your answers of factoring by multiplying back out what you had before. Okay, so I'm gonna just kind of go up here for just a second before we get into maybe some of the factoring. I want to look at a couple of these. Let's look at this number 1 and number 2 here, just because I don't have any of those on the review, but they are definitely things that I want to make sure that you know how to do. So on number 1 here, right, it's asking you to multiply. And if it was like a binomial times by a binomial, then we talk about that as FOIL. But really what we're doing when we're multiplying is that we are distributing. It's just the distributive property that we are doing twice. Okay, so let me show you what I mean by that. So it doesn't matter how many terms in each of them we're doing. We're going to take this 2x and we're going to multiply it by the first term in this. So 2x times x squared is going to give me 2x to the third, because remember, there is an invisible 1 exponent on here, and we're adding those exponents together when we're doing this multiplication. All right, then let's continue this. So if we distribute that through to the next term, then 2x times negative 4x is negative 8x squared. And then 2x times 6 is positive 12x. All right, and now we need to take that negative 1 and distribute it through to everybody. So negative 1 times x squared is negative x squared. Negative 1 times this is positive 4x, and then negative 1 times this last term is negative 6. And then the last thing that we need to do is just get our like terms together. So I can see on this that, well, 2x to the third doesn't have a like term, right? There's no other x cubes in there, so it's just going to come down as part of our answer. But then I can see I have a negative 8x squared and a negative x squared. So negative 8 minus 1 is negative 9. So I get negative 9x squared for my x squared parts. Then if I look at my x's, I see I have 2 of those I need to combine together. So 12x plus 4x is going to give me 16x. And then again, that last term, that negative 6 doesn't have anybody to combine with, but it still needs to be part of the answer. So that would be the answer that we come up with there when we're multiplying that. Okay. Now, I'm going to do this number 2 and also with subtracting. If we, need a few more examples of how to do some types of factoring, I have a few listed out here, but we'll go to the review first and work through those problems. And then if you want to see some more, we have some options there. Okay, but number 2 on here, when it's telling you to subtract this, so I'm having, so 4x squared minus 7x minus 1, and that's all being subtracted, right? So subtracting off of that. So it's in parentheses, so I know all of this is being subtracted, is x squared plus 2x minus 6. And so basically what I have here, all right, and be careful with this because sometimes people look at this and think that it is multiplying like we did up here. But notice there's no symbol in between my 2 parentheses there, right? That's what's telling us it's multiply. Here, it's subtract, right? Because there's that subtraction sign. But really what we want to do here is this is kind of like a negative 1 that we want to make sure that we're distributing to everybody, all right? And so when I do that, I'll have 4x squared minus 7x minus 1, none of these changed, all right? But now if I'm distributing that negative 1 through, really I'm just changing the sign in here, right? And I've got to do it of all of these terms, so I get negative 1 times x squared is negative x squared, negative 1 times 2x is negative 2x, and negative 1 times negative 6 is positive 6. And again, just like we did up here, now we just need to combine our like terms together. So I can see my 4x squared minus x squared, right? Remember, this is like a minus 1. So 4 minus 1 is 3, so I get 3x squared. And now I need to do my x terms, right? So negative 7x minus 2x is going to give me a negative 9x. And now I need to combine those last ones together. I get negative 1 plus 6, which is going to give me a positive 5. And so that together will be my answer. Okay, so distribute that negative through first. Make sure you do that on the subtraction ones, and then combine your like terms together. All right, any questions on this specifically that you want to look at?
So do I have to write to underline the terms when I combine them together?
Nope, I just do that on here so everybody can see which ones I'm combining together.
Okay.
It just helps
so
me
we don't need
Nope,
answer, right?
nope. Just as long as you show me some work there. In fact, some students would rather write these underneath each other, and I kind of like that. So instead of, like taking all three of these terms, right, and they like to put it right underneath here so that your like terms are combined together. So let me show you what I mean by that over here. So if I had 4x squared minus 7x minus 1, and then sometimes people like to put that negative x squared minus 2x plus 6. And then it's just a little bit easier to get those like terms, because they're lined up there. And so, so you could do it this way even, if that way, makes a little bit better sense for your brain. However you want to show your work, just make sure that some work is shown, because that's how I can give partial credit on this. And if no work is shown, then I can't. And also be careful, because like the testing center will give you scratch paper, but they will throw it away at the end of the test. So everything that you want me to see needs to be written out on this test. I will not see your scratch paper. So make sure all of your work is shown on the test. And I try and give you plenty of room to do that on the scratch paper, is just in case you need, a little bit more work to, work out a problem, kind of figure out in your mind how to do it, and then you can just transfer that work that you want me to see onto your exam. Okay. All right. Any other questions so far on those two examples? All right. So someone asked about this factoring question that I will I'll look at and do here, because I think I have one kind of like it, but let's go ahead and work it out to the side. So let's do this factoring problem. So they said, so 12x squared minus 11xy, and then minus 5y squared. Okay. All right, so we're going to do this one in just a couple of minutes because it's a trinomial, but I do want to look at some other types first, just to make sure that we're good with it. I kind of wanted this to be in a little bit of a different order that I have here, but so again, I want to remind you to factor out, always, always, always look for first, is there a greatest common factor that I can factor out before I start doing any of the other factoring, okay? And so some of the methods that were talked about, and one of the first methods that was talked about was right here on this number 3, where it's saying factor this, right? And notice that there are 4 terms to it. So when there are 4 terms, you should think factor by grouping. Right? Sometimes it's easy on the test to kind of there's so many different ways to factor. So I understand like sometimes looking at a problem going, I don't remember how to do this. Okay, so try and remember 4 terms factor by grouping. So to do that, we're going to split this in half here. Okay, we're going to look at all of the terms first and see if there is a greatest common factor that can come out of all 4 terms. And there's not. Right, the first 3, like a 2 and an x can come out, but that can't come out of that last term there. All right, so there's not something that can come out of everything. So now, after we break this in half, we're just looking at those first 2 terms and saying, okay, what's the greatest common factor I can find just with these 2 terms? All right, can anybody think of what that might be? What could factor out of that? It's the biggest number. So we've got 12 and we've got 42. Can 12 divide into 42 evenly?
I don't think so.
Okay,
is it 2?
Something bigger than 2 can even come out. So 2 does divide in.
Is it 6?
It is 6. Yep. So, I mean, 3 would divide into both of them again, but 6 is the largest one, right? So you're looking for the biggest one that can divide into all of the numbers. Okay. So let's go ahead and do this. So we have, 6, and then if we look at also our variables, we've got an x squared and we've got an xy. So that means an x is also common to both of those that can come out. All right, and then really what we're doing here, and maybe let me move this down a little bit because sometimes it is easier for people to kind of think about this. So what we're doing with the 6x is we're basically dividing both of these terms by a 6x to figure out what's going to be left over. And we put those leftovers in the parentheses here. So if it helps you to write it down like this, showing that when you're factoring, you're dividing, then do that. It might be helpful. So 12 divided by 6 is 2. X squared divided by x is x. All right, so my leftovers here after I divide 6x out of that first term is 2x. Then let's look at the next one. Well, 42 divided by 6 is 7, a positive 7, so plus 7. And then I have an x on the top and an x on the bottom, so that x divides out and we're just left with a y. All right, everybody seeing that? Okay, and then we have left over here plus, I'm going to write it down this way just because I want to make sure we're kind of looking at something here, plus 2xy. Now people look at this and say, well, what is my greatest common factor there? All right, people are like, there isn't one. But there is, that greatest common factor is just a 1. And so I know that's kind of, a little bit, confusing sometimes people look at that. So I'm going to write this down as though I took, divided a 1 out of everything. Let me see if I can make that look a little bit more legible. Okay, so let's see. So this is going to be plus 1 times all of that. Okay, so now that we have that, we're looking at it and saying, well, these 2 in the parentheses are exactly the same. And that's what they need to be in order to do this factor by grouping. So now that's my greatest common factor that can come out. So I put that 2x plus 7y in one parenthesis, and then my leftovers are 6x plus 1, which goes in my other parenthesis. Okay. And so that is factored. Now, how could I check to make sure that this factorization is correct?
By distribution.
Yeah, distributing, foiling, however you want to say it, multiplying those through, right? And even if you just do like a quick check in your mind, you don't have to show like the check out to the side, But, if you want to show it, that's great. It usually will only take you like a minute or so to do it. And so that way you can make sure that you have the correct answer. So if we multiply this out, 2x times 6x is 12x squared. 2x times 1 is that 2x that we have there. 7y times 6x is that 42xy. And then 7y times 1 is that 7y. So I can see, yep, when I multiply that out, I get back to what I started with. So I definitely did that correct. Okay. All right. So that, if there's 4 terms, all right, think of that factor by grouping. All right, let me look and see here. Sorry, I kind of went.
Sorry, I just have a question about this question.
Yeah.
So first, can I do like first, like for this first term, put between parentheses, and the second 2 terms between parentheses, then start to find the common factor?
Use numbers and letters. I'm not sure which ones you're talking about.
Can I do the first step is parentheses 12x squared plus 24xy and close the parentheses, then plus open parentheses 2x plus 7y, close the parentheses. Then I can find the common factor between 2 terms for both.
Yep. So this line that I'm putting here, in the middle is separated in half for me. But if you'd rather, write these in parentheses like that, that's totally fine. Yeah. Okay. Just to make sure that you can see which ones you're working with. So just show me somehow how you're splitting those up, and that's great. Okay. Good. Yep. Thanks for your question. Okay, so let's look at a couple of things here now. Let's see, we didn't really have one like this because it's kind of one of the easier types of problems. But I wrote it up like one up here like this, so, oh, maybe I didn't write one there. Thought I had. Okay, let me see which one I meant to have here then. So let's try something like this. What if I'm asked to factor x squared plus 8x plus 12. Okay. So notice on this one, and this is kind of something that I went over again in that video that I sent you in the announcements about factoring. So go back and look at that one again too if you need some help with factoring. But on one like this, we notice that our leading coefficient is a 1. And so when that's a 1, we can actually, there's not a lot of work that we have to do on this. We can go straight to our parentheses. Okay, and so then you're going to ask yourself, what multiplies to be 12 that adds to be 8? All right, so I'm just writing that above there just to help you see. So what multiplies to be 12 that adds to be 8? Well, if you need to kind of exhaust your possibilities, all right, and work organized, we're saying, okay, well, 1 times 12 is 12. All right, what else is 12? Well, 2 times 6 is 12. And 3 times 4 is 12. And so I've listed out all my possibilities, and notice how I'm working them. I wrote these down in an organized fashion. 1 times something, 2 times something, 3 times something. And then this 4, is right there next to it. So I know I have all of my factors here. Okay, now I'm looking to see which one of these pairs would add or subtract to be 8. Well, that looks like it's going to be this 2 and 6, right? That's our winning combination there. And so because this leading coefficient is a 1 here, I can go straight to my answer. And so I'll put in here, well, x times x, right, is my x squared. And then I found What multiplies to be 12 that adds to be 8? Well, we found that to be positive 2 and positive 6. And so now I have that factored. And again, if I FOIL that out, multiply that out, right, I end up with what I started with here. And so I know I did it right. Okay, however, most of our factoring, right, doesn't have just a 1 in front of this, in that leading coefficient. It's not just a 1. And so we've got to take that into account when we have something like this. So let's look at this number 1 here and talk about it. So our leading coefficient here is an 8, right, not a 1. And so when we have something like this, we've got to multiply that first and that last term together. Okay, now think about this. Let's go back to this one again. Right, really, we did that up here, but we didn't, right? So what's 1 times 12? Well, that's 12. And that's how I came up with those factors there. So it was because this is a 1 that last term is all we have to really look at. But when it's not a 1, we've got to look at both of these terms. So I'm looking at this saying, okay, well, what's 8 times negative 9? Well, that is going to be negative 72. So I'm thinking what multiplies to be negative 72 that adds to be that negative 6. Okay, then there's a lot of different ways that people, write this down. And again, like I am not set on a specific way. As long as you can show me some kind of work that you're doing, then you will get the credit on it, okay? It doesn't have to be the way I'm showing you here. Okay, so I'm going to think about what are my possibilities? What times what is negative 72? And so if I list out all of my possibilities here, well, I've got 1 times 72. And again, I usually just wait on that negative. So I'm just thinking what times what is 72, okay? 2 will divide into it evenly, 2 times 36. How about 3? Will 3 divide into 72 evenly? You guys see what I'm doing there?
Yeah.
And how many times will it go in? 3 times
24.
24, yeah. Okay, then you look to see, will 4 divide into it evenly?
To 8.
18? 4 times
No, I think
4 times 18 is 72, right? We're looking for what 72 is. All right, and then 5. Will 5 divide in? No. How about 6? So what's 72 divided by 6?
12.
12, yep. Okay. 7 won't divide into that evenly. 8 will. 8 times 9. All right, but you want to check everything. Like I can see on the top of my head that, like 5 won't divide into this evenly because if it was divisible by 5, it would end in a 0 or a 5. And so that's why I'm kind of like doing some mental stuff there, thinking about it, and if you're not sure about 7, right, then try and, just use your calculator to divide that in, and you'll see that will divide in like 10 point something times. And so it doesn't divide in evenly, so we can't use it. But then I'm back to my next number, 9. So I know I have all of my possibilities here. So now I'm looking to see which one of these could add or subtract to give us a negative 6. So which is my winning?
6 and negative 12.
Yeah, so 6 and 12, and I'm glad you said in order for it to be a negative 6, that 12 needs to be negative. All right. Okay, so then there's all sorts of possibilities you can do from this point. And like I said, in that other video I sent you, I showed you 3 different ways. You decide which way works best for you, or even if it's a different way, that's fine. On this first one, I'm just going to show the factor by grouping method, since we kind of did that one down here, so we can build on that. So this first term stays the same. I leave that as 8z squared. But this second term, right, I'm breaking down into what I found my winning combination to be. So I'm going to have plus 6z and then minus 12z. All right, because when I combine those together, I get that negative 6z that I'm looking for. And then that last term comes down and is, and now I have my 4 terms, so now I can do factor by grouping just like I did down here. Okay, so again, for me, I just like to split it in half, and make sure when you split it that you keep that negative sign with that third term. Sometimes people forget to keep it with it, and that way you might get off by a negative there. So make sure that's part of it there. All right, and then I'm looking again, just like we did before, what's my greatest common factor that can come out of 8z squared and 6z? What do you guys think? What's the greatest common factor there?
2z.
Yep, 2z. And usually with z's, I put a line through it like you can see here, because my 2's and my z's look a lot alike. So if you have that issue too, make sure you make clear so you don't accidentally make a mistake thinking that, oh, I thought that was a 2, not a z, right? All right, and then our leftovers would be 4z and then plus 3, right? I'm just dividing both of those parts by 2z. All right, how about these last 2 terms? What is my greatest common factor with those 2?
-3?
Yeah, -3. And I'm glad you said -3, because if this term right here, this third term, is negative, then we need to make sure we bring that negative out with it. Okay, so that is, because it's kind of like we have 2 different problems in one, and if our leading coefficient is negative, we always want to factor that negative out because it makes the rest of our factoring a lot easier. So when I do that, I'm left with 4z plus 3. And if I hadn't taken the negative out with it, I would have had negative 4z minus 3. And then, those guys wouldn't match, right? These 2, remember, need to match each other. So then that goes in one parenthesis, all right? So let's see, I'm just going to put the answer over here. So 4z plus 3 is in one parenthesis. And then remember, my leftovers go in the other parenthesis, which is 2z minus 3. All right, and so that is my answer. And again, if I wanted to check and make sure that I did it correctly, just FOIL that back out, right? Multiply it through, and you'll see that you come back with what you started with. Okay. All right, what questions do you have on that one?
Actually, I can easily do this by FOIL in just one step. But when I did that in the exam, you write a note like to show the steps. For FOIL, it's just one step for me. So how can I show the steps to get the last, this answer?
So you're saying you're doing kind of like a guess and check method?
Yeah.
Okay. So when you're doing it that way, just maybe just write down to the side what, the guess and check is that you're doing, because you're still thinking it through. You're asking yourself, what times what is 8z squared, right? And so you could list the possibilities there. Well, that could be 4z squared times 2z squared, or it could be 8z squared times 1z squared. Right? So what possibilities there? And then what possibilities are there for -9? Well, it could have, the 9 times 1 or the 3 times 3, and then, or, some of them being positive and negative too. So just writing just a little bit of something down there so I can see your thought process, because that's the most important to me, is how you're thinking through the problem. And like I said, like I don't care which way you do it, but just make sure it's really clear to me like how you're going through to do that. Okay?
Okay, so I have just to make sure to write like this list of suggestion for the first term and the last term.
Yeah, or sometimes people have, they use something like this little method where they're thinking, you know, what multiplies to be, you know, like that 8z and 9z. And so they like put it in this little X thing. If you've seen it like that, you can write it like that. But if not, just like this is fine. This isn't usually a way that I show in my classes, but it's a way that I see a lot of people doing it. And so I'm perfectly fine with that, just as long as I can see what it is you're doing to get there. Okay. All right, good question. Let's look at this one over here because somebody wanted to look at it. All right, so 12x squared minus 11xy minus 5y squared. All right, so somebody tell me, what is the first thing we would want to do here in order to factor this? I might just get rid of this stuff down here. Whoops. Why is it not erasing for me? Eraser is not working. My goodness. Do not know why it's doing that. Usually it doesn't do this. Okay, well, I'm trying to see if I can, I'm worried I'm not going to have enough room here to work this out. All right, but our first step, right, is that we need to multiply that 12 and the negative 5 together. So 12 times negative 5 is negative 60. So I'm kind of have to just write it up here, I guess. So I'm thinking, what multiplies to be negative 60 that adds to be negative 11? All right, and notice on this we've got some x's and y's, so we just got to be careful about that when we write it out in our, final factored form. But let's just first look at the numbers, right? So can anybody think what would be our combination here? What multiplies to be negative 60 that would add to be 11? Anybody know?
Well, oops. It's 15 and 4, sorry.
It is 15 and 4, yeah. Okay, so if you go through all the different possibilities, kind of like we did before, right? 4 and 15 is going to be what we want there. And we need our 15 to be negative, right? So again, when we write this out, we can have, all right, 12x squared stays the same. But then we're going to have 4 and negative 15. So minus 4x, or sorry, plus 4x, I meant, minus 15. Whoops, and I should say xy, because this term right here in the middle, that xy, both of these in the middle need to be xy. We're just breaking it down, right? So that if I combine these together, negative 15xy plus 4y gives me that negative 11xy. And then my last term is that minus 5y squared. And so now it's just like we did over here. We can do factor by grouping again if we want, okay? Or you could have done the box method, and I might show you the box method on another one here, right? But it's the same idea that what we've been doing before. So on the first two terms, I can see that 4x is what can come out of both of those terms. And that would leave me with 3x and then plus y. All right, and now I'm going to go to my second set of numbers here, negative 15xy minus 5xy, or 5y squared, I meant. Negative 5y is what can come out. And then leftovers would be 3x in that first term, and then just plus y in my second term. And then I can see, okay, my 3x plus y, right, goes in one parenthesis. And then my leftovers, 4x minus 5y, goes in my second parenthesis. Okay, now let me ask you this, and hopefully you've seen it on the homework, but does it matter which way I write these parentheses? So meaning, is 4x minus 5y times 3x plus y the same thing? Like, do we get the same answer? Because we said this was the answer. Is this second one also a good answer? What do you guys think?
Yeah, I think it's the same answer.
Yeah, it's the
Because
same. Yeah.
it's
Why do you think?
multiplying.
Yeah, it's multiplying, right? If we had like 1 times 60, that's the same thing as 60 times 1, right? It doesn't matter with multiplication, the order that we write it in. So as long as it's like that whole thing, the 3x plus y, is first, and then that 4x minus 5y is second, or the other way around, right? Either one is perfectly fine, and one is not more correct than the other either. So want to make sure that that's very clear to you. Okay.
I have a question.
Sure.
I have heard from my last teacher said that the first parentheses have to be the positive and the second parentheses negative. So is that correct, or it's okay?
Do you mean the sign in between it?
What was that?
I don't know what you mean by positive and negative. Do you mean the sign in between the two numbers?
The first one in the square, 3x plus y have to be the first.
No.
Then we get the parentheses of negative sign.
Nope, it doesn't matter. There's not, yeah, I mean, maybe that was that teacher's preference, but it is not one, it's not that one has to go before the other. Either one is perfectly, both of these are perfectly good answers. They're the same answers. Okay. So yeah, so I don't care which way you write it. It's both the same. Good question though. I'm glad you asked. Okay, let me scroll down here a little bit. And I want to look at just a few other types here. And I am focusing on factoring a lot just because so much of what we're going to be doing is factoring. Okay. And so, we're not going to do all of these here. I mean, you can work through some of these on your own if you want some more to try and practice with, right? But let's take a look. And there is one on, I think that I had listed above that somebody was asking about doing also. And I do want to make sure that we go through something like this. So let's look at this one. So if we factor 3x to the third minus 75x. Okay, so let's look at this one first. So when we're trying to factor this, what's the very first thing we always need to look for when we're factoring?
Common factor?
Yeah, greatest common factor. What do you see as a greatest common factor with both of those terms?
3x.
Yeah, so 3x can divide out of both of these, right? And when I do that, I'm left with x squared, and then 75x divided by 3x is negative 25. All right, so now can this factor any further?
Yeah.
Yeah, this x squared minus 25 is a difference of squares. All right, so when I'm looking at this, okay, so 3x stays on the outside, and then this, we're thinking to ourselves, what multiplies to be negative 25 that adds to be 0, because there's no x term in there in the middle, right? So that's one way you can think about it. Or another way that sometimes students think about it is, okay, well, what's the square root of x squared? Well, that's x times x. What's the square root of 25? Well, that's 5 times 5. And then in order to have like a 0 in the middle, right, there's like a plus 0x in the middle there, right? Well, one of these would have to be positive and one would have to be negative. And then that would be factored completely. Okay, if on the test you left it like this, you'll get a couple of points for factoring out that greatest common factor, but you won't get the full points unless you make sure everything is factored completely. Okay. Let's see here. So let's look at this one next. So this time, right, if we're looking at this 54a to the third minus 16b to the third. Well, I noticed that both of these have a power of 3 on them. So right off the bat, I think, okay, it's 2 terms. There's something cubed. So this looks like it might be a difference of cubes. All right, and it's a difference because it has the subtract sign in between it. But when I look at that 54 and negative 16, I'm like, wait a minute, those aren't perfect cubes. Because remember, some perfect cubes, these are good to make sure that you have memorized, just because it will make it a lot easier for you and faster. So perfect cubes are like, so 1 cubed is 1. So 1 is a perfect cube. 2 cubed, 2 times 2 times 2 is 8. 3 cubed, 3 times 3 times 3 is 27. 4 cubed, 4 times 4 times 4 is 64. And then 5 cubed is 125, right? So knowing up to at least there will be really helpful for you. Perfect cubes, cubed. All right, but I look at these numbers and I say, wait a minute, those aren't perfect cubes. So how can I do this? Well, what should I look for very first before I start even trying to factor it as a difference of cubes?
Common factor?
Yeah.
Like an active one?
Yep, just like over here, right? We came out, that greatest common factor was 3x. We got to look for a greatest common factor here. And you said 2, right? We'll factor out of those. So 54 divided by 2 is 27. So I have 27a cubed, and then minus 16 divided by 2 is 8. So 8b cubed, right? And now this can factor further because now I can see, oh yeah, I do have some perfect cubes here, right? So I can do this. So remember that make sure you have these difference of cubes and sums of cubes memorized. Okay, so I'm going to put this up here just to make sure. And this is something that, I would make sure, in case you're worried you're going to forget it, just write it at the top of your page, right at the beginning of the exam, right? If there's anything that you need to memorize that you're like, oh, I'm afraid I might forget that, just put it somewhere on the top of the test so you can look back at it. All right, so a cubed plus b cubed factors to be a plus b times a squared minus, ab plus b squared. And then if I have a difference of cubes, so a cubed minus b cubed, they're really similar to each other, right? It's just signs are different. So it starts off with a minus b, and then over here I get a squared plus AB plus B squared. And so there is a little acronym here that they tell us to always use SOAP when we're thinking about these sum and differences of cubes. And that's to help us remember the signs. So the S stands for same. So whatever was started off here, right, that plus, it's going to be the same, that first sign in here. All right, this was minus, so it's the same here. All right, the next letter in there, O, means opposite. So our next term is going to be the opposite of what it started off with. So this was plus, now it's minus. This was minus, now it's plus. Okay. And then the AP there is together, and that is always positive. So notice that this last term here is a positive and a positive. That last term will always stay positive, right? So same, opposite, always positive. Because those are so similar to each other. It's just keeping track of those signs that's really important for you. And so when I'm looking at this, I kind of want to break it down because I don't have it written as something cubed minus something cubed yet. So I kind of need to change this a little bit. Meaning, so I'm going to keep the 2 on the outside here, but my 27 a to the third, right? I'm trying to think, and so sometimes there's some people, they'll think about, you know, taking the cubed root of it, or what times what times what is 27, right? We can see that over here is 3. So 3, and then I've got a cubed, so that would be a, and so all of that cubed, right? So if I have 3a all cubed, that is saying 3a times 3a times 3a. If I multiply those all together, I get 27a cubed. And then same kind of thing over here. I'm thinking what all cubed gives us that 8b cubed. Well, the cubed root, or what times what is 8? That would be 2. And then what times what is b? And that would be b. And so now I have 3a, just that part, is my a in this little formula that I'm going to use up here. And that 2b is my b part. Okay, so when I am using this, so let me try and do this over here. So again, I have my 2 is on the outside. Okay. In my first parenthesis, I need to do a minus b. Well, my a here is 3a, and then minus 2b. Okay. Now, for my second part of my parenthesis, I'm going to take that a, whatever it was, and square it. So I'm taking that 3a, and I'm squaring that whole thing. Now you don't have to do it in, like you could have, you know, written this out is, you know, is the answer at this point. But for making sure that everybody's with me, I'm going to write it out this way. Okay, just like show all the work. And then my next thing says I need to do plus a times b. Well, a times b, 3a times 2b is going to give us 6ab. So plus 6ab. And then the last term here is b squared. So taking this b that I have, which is 2b in this case, and squaring all of that. So plus 2b squared. I am so sorry. This is like, should have written it a lot smaller, but let me go ahead and do this again down here. So 2, and then 3a minus 2b. But now I need to, you know, make this, like I need to simplify this more. So 3a times 3a is going to be 9a squared. All right, so don't leave it as 3a all squared. Make sure you multiply that out to be 9a squared. That 6ab, there's nothing more to simplify there. But on the last one, we have 2b all squared. So 2b times 2b is 4b squared. And so that whole thing would be my answer on this one. Okay. Questions on that? Those difference of cubes or sum of cubes? And then I just always double check that I use SOAP, right? Meaning I look at it and say, okay, this is the same. This one's opposite. And this one's always positive. So yep, I use SOAP. And so I know that I have at least the signs right on there. But, you know, make sure you have these guys memorized. All right, go in having those memorized. Otherwise, that's going to be really difficult to try and factor without having that little formula to follow there. Okay, I'm going to move down and get into some other things. We are going to still be doing some factoring with what we're going to be doing, but this will, you know, we'll be able to use some factoring with what we're doing here. So this one says solve by factoring. All right, so if I'm solving something by factoring, I need to get everything over to one side and put the other side equal to 0. And so right now I see, okay, I've got this negative x squared, and I need to get it over to the other side. I want everything over on one side. And so I'm going to choose to add my x squared over here. Okay. And that's because it's going to keep that first term positive. So when I add that over, I have x squared minus 3x minus 18, and then left over here is 0, right? That's what I was trying to do, get everything over to one side and put the other side equal to 0. All right, I notice here that my leading coefficient's 1. So that I can go straight to the parentheses and be able to see what I'm doing here. So what multiplies to be negative 18, right? So that would be, we got 1 times 18, 2 times 9, 3 times 6. All right, that adds to be negative 3. Well, that would be using these two. And if 6 was negative, that would add to be negative 3. So I've got x plus 3 and x minus 6. Okay, now I'm not done at this point, so be really, really careful, right? It's saying solve by factoring. So I've got to make sure that I am finish this out and I'm solving it, right? I factored it, but I'm not done yet. So on the quiz that you guys took, and I gave you feedback on it, some of you accidentally stopped at this point when you should have kept going. All right, so now in order to solve it from here, I set both of these parts equal to 0 to solve. So I have x plus 3 equals 0 and x minus 6 equals 0. And then I just need to get that x by itself, so I'll subtract the 3 over there, so I get x equals negative 3. And here, when I add the 6 over, I get x equals 6. All right, so my answers are going to be negative 3 and 6. Okay, so just be careful. Make sure you're noticing, is it telling you to just factor it, or are you solving it? Okay, pay really close attention to that on the exam for sure. Okay. Now on this one, I kind of wrote over the top of it. It might be kind of hard to see here, but it says, maybe I'll just write it over here. So 6a squared equals 8a. Okay, so again, to solve this by factoring, all right, I've got to get everything over to one side and put the other side equal to 0. So I'm going to subtract the 8a over. So I get 6a squared minus 8a equals 0. Okay, now how can I factor that? What do you guys think here?
Greatest common factor.
Yeah, always look for that greatest common factor. What is the greatest common factor of those two terms?
2a.
Yep, so 2a comes out. And then what are we left with?
3a minus 4.
Yep, 3a minus 4. and then equals 0. Am I done?
Not yet.
Not yet, right? It's telling me to
2a
solve.
equals 0.
Yep, 2a equals 0, and 3a minus 4 equals 0. All right, so now let's solve each of these. To get a by itself here, it's connected by multiply, so let's divide both sides by 2. Well, 0 divided by any number is just 0, so a equals 0 is one of my solutions. Here I need to start by adding the 4 over. So I get 3a equals 4, and then divide both sides by 3, so a equals 4/3 would be my other answer. Okay, and notice there's something here that I want to point out to you that may not have been pointed out in the videos to you that can be really helpful. But notice like our highest exponent in this first one, right, is a 2. Our highest exponent in this one is also a 2. That's telling us how many total answers we should end up with, right? We ended up with 2 here. We ended up with 2 here. If that highest exponent was a 3, then I would expect to get 3 answers, right? If the highest exponent was a 4, I'd expect to get 4 answers, and so on. So that degree of the polynomial is telling me how many solutions I get when I solve that polynomial. Okay. All right, now on the last test, there was definitely some questions about finding the domain, and some of you kind of had a struggle with it, so hopefully this will kind of redeem you. You can kind of, hopefully you looked through that exam, you saw what feedback I gave you there. And so here we have something that is being divided, and so whenever I have that, remember, I can't divide by 0. I'm going to write that over here. Can't divide by 0. All right, it gives me something undefined. And so basically on this, I need to figure out what x values are going to make that 0, because those are the things that x can't be. So in order to do that, we're just going to take whatever is in the denominator. Right? We don't care what's in the numerator at all. Just take what's in the denominator, and I'm going to have x squared minus 3x minus 4, and I'm going to say it cannot equal 0. Okay? Now on the videos, they may have shown you just equal 0, but I like putting this cannot equal 0 because then it becomes more clear in your mind at the end that, oh yeah, those are the things that can't be. It can be everything but those. All right, but to do this, we want to factor it just like we did above when we were trying to solve it. So let's factor these. So this factors to be x times x is x squared. What multiplies to be -4 that adds to be -3? Well, that's going to be a -4 and a +1. Okay. Again, I'm putting cannot equal 0. Then I'm looking at each of these separately. So x minus 4 cannot equal 0, and x plus 1 cannot equal 0. And again, if I solve these, add the 4 over, I'm saying x cannot be +4, and subtract the 1 over, x cannot be -1. All right, so those are the two things it can't be. Now, if it asks for just the excluded values, you could just leave it like this. Okay, and I'm going to write that out to the side. These are the excluded values, meaning it can be every other x value except for these two. But notice here it tells us to write the domain of it. So I'm just going to write a little graph up here because sometimes it's easiest to see the graph or see what the domain is if we know what the graph is. So we're saying, okay, here's -1 and here's +4, right? This is a number line. I'm just writing those out. And we're saying it can't be -1, so there's like a hole in the graph there, and it can't be +4, so there's a hole in the graph there. But it can be everything smaller than -1. It can be the stuff between -1 and 4, or it can be the stuff bigger than 4. It just can't be those two values. Why can't it be those two values? Those are the two that would make us divide by 0, and we can't divide by 0. Okay, so writing this out in interval notation, I'm looking at my graph from smallest to biggest. Well, this is going clear out to negative infinity. So I've got parenthesis, negative infinity to -1. All right, and again, another parenthesis because it's an open circle there. It can't be -1. All right, now I need to say the stuff in between here, so I'm going to put a union. And then the stuff in between is -1 to 4. And then I need to put another union because that's not all. I still have this stuff over here. So union, parenthesis, 4 to infinity. And so all of this is my domain. Okay, so if it asks you to write it as the domain in interval notation, this is how you write it. If it just asks for the excluded values, then you write it like this. Okay, what x cannot be. So just make sure you notice your directions carefully on what it's asking you to do there. Okay. Questions on that? Like I said, that was kind of one of the questions on the last exam where there was some people that missed it. So this is giving you another chance to kind of make sure that you understand domain really well. And when we have a fraction, we just got to look to see, okay, which numbers would make us divide by 0, because we can't divide by 0. Okay.
So, just so I understand this,
Yeah.
it's always easier to see it as an excluded value rather than, okay, because I always get confused about having to write it into the interval notations when you're looking for the domain. And I always end up just putting -1 and 4, but you say it's better to do the negative, the equals, not to, when we're solving this type of question.
Yeah, cannot. All right, this is saying x cannot be 4 and x cannot be -1. Yep.
Okay.
Yep, those are those.
Thank you.
Yep, those are the values that can't be. And once you know those, then it's easier to write it in interval notation like this, because we're saying, okay, everything but -1 and +4. And again, looking at a graph kind of can help you write that interval notation down too. So even though it doesn't tell you to graph it, that's just something that can help you write it out correctly. Okay,
Okay, thank you, because I did miss this one in my exam in 1, and it's much clearer to see it like this.
awesome.
Solving for the exclude. Yeah, thank you.
Yeah, you're welcome. Yep. Okay. All right, let's look at this number 11 now. So this is kind of like a little story problem involving trying to, use something that we're trying to solve for here. So a toy rocket is launched vertically with an initial velocity of 128 feet per second. The height is given by this, right? So h of t is talking about the height. Let's see if I can write that up here without it being too, right? So h of t is the height, and then t is the time in seconds, because it's telling us here feet per second. So time is time in seconds. Okay, and just making sure that you understand that is really important in just understanding this problem well. So think about this, right? It's saying it's coming from the ground. So I'm just going to draw a little picture over here at the side because sometimes it's easier to see. So it's starting on the ground, it's going up to a certain height, and then gravity is going to bring it back down to the ground, right? And it makes this like upside down parabola shape when we are, something goes up into the air and then it comes back down. Okay. So when does the rocket hit the ground? After it is launched, right? So it started on the ground here, and we want to know when it gets back to the ground. So when it's saying when, all right, that's talking about the time, right, in seconds. So we're trying to find t on this. because that's what we want to know, what t is. And what is the height of it? So when it hits the ground, what is the height of the ground? That is 0. So it's not really telling you, but it is telling you, right, that you're going to have h of t is going to be 0. So I'm going to put 0 in place of my h of t because my height is 0 equals negative 16t squared plus 128t. And now I need to solve this, right? What I'm looking for is the time. I need to solve it for t. Well, how do I go about solving something like this? Well, I've got to factor it in order to figure this out. All right, so I can see here that there is a greatest common factor that I can take out. Now, can 16 divide evenly into 128? That's where I would start first. And if then 16 doesn't work, then I'd look to see, well, can 8, because 8's a multiple of this, or a factor of that. And then does 2 or does 4, right? But start with that biggest number first and see if that whole thing will divide in. And so 16 does divide into that. So, and since this is a negative out here, I'm actually going to factor out that negative 16. All right, both terms. And I can see, well, this one has a t squared and a t. So another part of my greatest common factor is that t, right? So negative 16t is my greatest common factor. What am I left over with when I factor that negative 16t out?
E plus 8.
Yeah, t, and then 128t divided by negative 16t is going to be negative 8.
Negative 8.
Okay. All right. And then now, just like we did above, we're going to set both of those parts equal to 0 and solve, right? So this is, we're trying to figure out what t is, not excluded values like this one here, but like what we did up here, right? To figure out, we're solving for t on this. So I've got negative 16t equals 0 and t minus 8 equals 0. So here to get t by itself, let's divide both sides by negative 16. 0 divided by anything is just 0, so t equals 0 is one of my answers. And then add the 8 over, so t equals 8 is my other answer. Now again, I need to make sure I have labels on this, right? Because word problems need word answers. So this is the time in seconds, right? T equals 0 seconds is actually where it started off here, right? This is a 0. And then it ended. What it wants to know is when did it hit the ground after it's launched, right? So this really isn't the part that we want. We really want to keep this one, which is it's going to take 8 seconds for it to hit the ground. All right, so it's going to start here, go up, and then come back down 8 seconds later. All right, what about this part B? Because sometimes this throws people off. When does the rocket reach a height of 256 feet? So what do I need to do with this 256?
Substitute an h.
Yeah, so substitute in for that height, that h of t.
Yeah.
So, yep, so I'm going to have take that h of t out and put in 256 instead, because that's the height, and then equals the rest of that, negative 16t squared plus 128t. Okay, now what do I do from here? So I'm trying to solve, right? Again, it's saying when. So it means I'm trying to find the time in seconds. So I need to solve for t. How would I go about solving this for t now?
Subtracting 256.
Yep. Got to get everything over to one side. Put the other side equal to 0, right? So this is gone, leaving 0 equals negative 16t squared plus 128t minus 256. Okay, so now what can I do with this?
Common factor.
Yeah. So what is our greatest common factor that can come out of all three of these terms? Again, start with negative 16, right? See if it will divide into all of those. And then if it doesn't, go, okay, well, what's another factor of 16? Well, there's 8. Okay, let's see if that one goes in. If that one doesn't, then go, to 4 or something. But always start with that biggest number. That's usually what it's going to be. So negative 16 can divide out of all of those. There's not a t this time because this guy doesn't have a t, right? So just negative 16 comes out, and that's going to leave us with t squared minus, well, what's 128 divided by negative 16?
80.
Yep, so 8, and then t, and then what's negative 256 divided by negative 16?
16.
Plus 16. Okay. And so now we just need to factor this to solve it. All right. And again, our leading coefficient's 1, so that's good, right? So we can say t times t, and then this is going to be negative 4 and negative 4, right? Negative 4 times negative 4 multiplies to be positive 16, adds to be negative 8. Now, this part is what I want to make sure is clear to people because they think they have to use it. There is no t to solve for here. So if you try and say like negative 16 equals 0, that's just nonsense, right? Negative 16 doesn't equal 0, and there's nothing to solve for there. So really, we're just looking at these two, but specifically, I mean, these are both the same, right? So I can just do it once. T minus 4 equals 0. Add the 4 over, t equals 4. So it's going to reach that height of 256 feet at 4 seconds. So I'm going to say 4 seconds at 256 feet. All right, and over here you could say like 8 seconds to hit the ground or something like that. All right, it's just good like to put like word questions need word answers because that's just helping you make sense of it, to think, does this make sense? Well, yeah, it took 8 seconds to hit the ground, and so this 256 is probably up here, right? About halfway through there. Okay. Okay, let's see here.
I just have a question for this question.
Sure.
Can we cancel negative 16 by dividing both sides by negative 16? So we're not gonna go following mistakes when we solve for negative 16, right?
There's nothing to solve for with negative 16.
Yeah, but I meant instead of factor negative 16, we can substitute all the equation by negative 16, then we're gonna cancel it.
I'm not sure. You mean here like divide both sides by negative 16?
Yeah?
Yeah, that's fine. Because you'd be doing 0 divided by a number which is still just 0. So yeah, if you wanted to move that over that way, that's perfectly fine. Because you'd still end up with the same thing, right? That t equals 4 seconds. You bet. Yep, that's great. Okay, let's look at a few more here. So this next stuff is dealing with, a lot of like division and stuff like that. And so I want to make sure that when you are dividing or you're multiplying with these polynomials, all right, and if you read my last, I think I put it on the last one, maybe it was the time before that, but I think it was this last one, where it tells you to divide first and then simplify second, right? Cancel second. But you got to oh my gosh, I'm saying this backwards here. Okay, hold on. You got to factor first is what I meant to put, then divide. don't know where my brain is. Okay, so we're always going to factor first, right? Then divide. That's how I want you to think of it. So I'd say the most common thing that I see people do on this that is a big, huge no-no that I don't want to see any of you do here is they look at this first one here and they're saying, oh, I've got 25m squared and 25m squared, and they try and just divide those out. Well, you can't divide those out because these are connected by subtraction, right? You can only divide things out if they're connected by multiplication. And so that's why we've got to factor everything first, because when we put it in factored form, we're putting it into multiplication form. And so that's what I want to make sure that I do first, right? So factor, factor, factor. If you get stuck on these problems, I'd say, stick with this, right? Think, okay, what can I factor? What can I factor? That is going to help get you there to your answer. You can't just cancel these sums and differences out. That doesn't work, right? We can't do that. So let's factor this out. Well, this looks like a difference of squares. And so that's going to factor to be 5m minus n times 5n plus n. All right, and again, like going back to what we did before with the factoring, look back to where we did the difference of squares, right, to how to get there, because I don't. And then on the bottom, this is a trinomial now, so I need to think about, what I'm doing here. Well, what times what is 25? Right, so this one, it's a little bit, trickier for some people because they're thinking, oh, that n squared is their second, right? But really, I can see that this is a perfect square trinomial. So meaning this is going to be 5m minus n, and then 5n minus n. All right, if I FOIL that back out, you'll see I get 25m squared, and then minus 5mn, minus another 5mn, and then plus n squared. Okay, so you can just kind of look at that, do it the factoring the way that you're used to doing it. But however you get there, you got to factor everything first. Then I can see those two are common factors, so that whole thing, right, has to divide out, because I can only divide things out when they're connected by multiplication. And so then my answer is just this, okay? I can't do anything more than this. So be careful, like I don't want to see people going, oh, well, I can factor this 5m with this 5m and this n with this n. No, you can't do that because, again, right, we can only factor things out when they're connected by multiplication. So this whole thing would have to be exactly the same of what it is on the bottom in order to factor out anymore, and we can't, so we're done. Okay, similarly down here, but this is a division problem, right? And so remember, when we're dividing, to change it to multiplication, we need to flip that second fraction. Okay, never flip the first fraction. You always need to flip the second one. So the first one's going to stay the same. I'm just going to rewrite it here. Maybe I'll put it over here just because I'm going to kind of run out of room here. So I'm going to have 3m minus n to the third, or sorry, m to the third minus n to the third. I don't know why m and n's are always tongue twisters for me. Right, m squared minus n squared. And then, like I said, I'm going to flip this. So I'm going to have an m plus n on the top, and then this trinomial on the bottom, m squared plus mn plus n squared. Okay, so again, we're going to follow this advice here, right? Factor, factor, factor everything first that we can. So I see on the top here, this m to the third minus n to the third, that is a difference of cubes. And so we talked about that above on how to do that type of factoring. So go back up there if you can't remember how to do it. but we're going to have in our first parenthesis m minus n, right? Because we got to do the same sign that was there. Then I'm going to square my m, so m squared, and then times the two together, but I need to have it as addition, so plus mn, and then take that last one and square it, so plus n squared. All right, and then on the bottom, I've got, or actually, let me just write out the rest of this on the top. So this is being multiplied by m plus n. So I usually just write it all out as one big fraction because anything on the top will be able to multiply with anything, divide out with anything on the bottom. All right, so let's look at this part next now. So this is a difference of squares, which would factor to be m plus n times m minus n. And then this, do you notice that it is the same as that one is right there? And if you try and factor this further, it will not factor any further. So it's always good to just kind of look and see. Sometimes there's clues in the question to kind of go, oh, wait a minute, that whole thing will be able to divide out, so I don't need to try and factor that any further. All right, the other thing that I can see that will divide out is this m plus n divided by that m plus n. And then this m minus n will divide out with that one. So what is it that I'm left with? Everything divided out. Remember, when I'm dividing it out, I'm making ones, right? It's like this divided by this is 1. This divided by this is 1. This divided by this is 1. I'm always making ones. And so all I'm left with is 1. Right? It's not 0, it's 1, because I have 1 times 1 times 1 on the top, 1 times 1 times 1 on the bottom. So 1 is my answer. Everything ends up dividing out, leaving me a 1 there. Okay, and I know we're a little bit over on time. We kind of got a little bit of a slow start because I was in that meeting, so I'm sorry about that, but we're going to do just a couple more here just to make sure everybody is feeling good and comfortable with what we need to do. Make sure you know how to add and subtract these rational expressions also. Right? So if we're trying to add or subtract these, we must have a common denominator, right? So in this, you can't get rid of your common denominator. You've got to have a common denominator, right? So I'm going to put that here. Get a common denominator. That is really important. Whoops, combination, denominator. Okay, so to do that, it's going to be easiest by factoring the denominators first. So if I go ahead and just kind of move this over here, right? So I've got x plus 1 over, well, x minus 2, that can't factor anymore, so I'll leave it like that. Then minus 4x plus 7, and then I need to look at this denominator here, and I see, oh, there is a greatest common factor that I can take out, so this can factor more. 5 comes out, leaving x minus 2. Okay, so when it's in factored form, it's easier to see, oh yeah, okay, so I have to have exactly the same thing. This denominator has an x minus 2. This has a 5 times x minus 2. Right, so my LCD on this is going to be 5 times x minus 2. And so when I write out my next step, right, you can write it down as 5 times x minus 2, and then minus 5 times x minus 2. So if I'm comparing this x minus 2 with this 5 times x minus 2, well, that means that there is a 5 that's missing. Right, so I need to multiply that bottom by 5, which means I need to also multiply the top by 5. So on the top, I get 5 times x plus 1. And then here, I can see, oh, I've got 5 times x minus 2 and 5 times x minus 2. So there's nothing, like that doesn't change, so the top's not going to change. However, be really careful with this minus sign, right? Because this is kind of saying like, I'm taking a -1 and I need to distribute that through. Okay, so I'm going to change this. Instead of being minus here, I'm going to change it to a plus and then distribute that negative. So -4x and then -7. You've got to distribute that through. The most common mistake here is I see that people give that negative to the 4x, but forget to give that negative to the 7. Okay. All right, so now I can write this all out, right? I've got a common denominator, so my common denominator is 5 times x minus 2. And here I need to distribute that through. So I get 5x plus 5, and then here I have minus 4x minus 7. So now I just need to get my like terms together. 5x minus 4x is just x. And 5 minus 7 is 2. So I've got x minus 2 over 5 times x minus 2. Am I done?
Nope.
No. Can you see that I have that x minus 2 can divide out with that x minus 2? All right. And so what's left on the top? Well, there's just a 1 left on the top there, and a 5 left on the bottom. So my answer is 1/5. So make sure, we always like trying to, the very last step when you're adding and subtracting is to try and see, will there be anything else that can divide out there? Okay. All right, I think just do that one. Let's do 16 here. And then I remember. Oops, I had. Oh my goodness. So I spent a lot more time on factoring than I thought I did, but I think it's just because I don't have you guys in class, and so I just am like, oh, there's just so much that I need to tell you and make sure that you understand well. Okay, so when you're doing something like this is a division problem. And I know it looks really weird, but if it helps you to write it out just as 2 over m minus 3n, and then divided by 1 over 3n minus m, like you can write it like this if you want to, but you could also, there's, another way that it was talked about in the videos and stuff that you can do it, just leaving it as this complex fraction, right? But if we do it this way, I just want to show you, that basically when I'm dividing, remember I'm flipping that second one there. So I've got 2 over m minus 3n, and that's times by 3n minus m over 2. Or sorry, over 1. Why did I say 2? There's just a 1 there. Okay. And so from here, right, you could, kind of look at it and go, okay, wait a minute, there's, not much there that I can actually do, right? Because there's nothing I can factor, right? 3n minus m doesn't factor, m minus 3n doesn't factor. So I could just multiply across the top, multiply across the bottom. However, these are kind of similar to each other. And so I would say it would be best to rewrite this. And maybe I'll just change it here. Let me show you this. It might be easier to see. So do you see, like, this one has the m written first and this one has the n written first? What if we change that around so that we have negative m plus 3n? Then it's easier to see, oh, these are almost the same, except I need to divide a -1 out of this. If I factor a -1 out of that negative m plus 3n, then it's going to be the same as what I have on the bottom there, right? So let's do that. So I have 2 over m minus 3n, And then up here, I'm going to factor out a -1, which is going to leave me with m minus 3n. Again, this is still all over 1. So now I can see I've got a common factor, right? This is common with this. And then if I multiply across the top, 2 times -1 is -2. So -2 would be my answer on that. Okay, so that's one way you could go about it. But like I said, like if there's a way that you know, in the homework that you've been practicing that you're like, oh yeah, I liked that way, you know, better, then use whichever way works best for your brain. That's what I always want you to do. Okay. I think we might end up going about 15 more minutes here. And if you need to go, I totally understand, but you can come back on and watch the end of this if you can't stay, but I hope you can stay. Just 15 more minutes here. All right, so this one, we're solving, right? We're not just adding or subtracting. We're trying to figure out what m is. So the easiest way to go about doing this is, again, start off by factoring everything in the denominator, because we want to figure out what the LCD is, not necessarily to make a common denominator. You can go about it that way. But the awesome thing about this is if it's an equation, right, it has an equal sign in it, we can actually kill off the denominators, which makes it so much easier to solve for. So let me show you what I mean here. So let's start by getting, you know, anything on the bottom factored. So I'm going to have -5m over, well, m plus 1, can't factor any further, plus m over, well, 3 can factor out here, so 3 times m plus 1, and then equals 56 over, well, here I've got a 6 that will divide out, 6 times m plus 1. Okay. So what is my LCD? So now it's in factored form. Now I can find my LCD easier, right? And the LCD needs to make sure that it has every single one of these parts. So I know that m plus 1 is part of it, right? And everything has an m plus 1 in it already. This one has a 3 and this one has a 6. Well, keep in mind that 6 is 2 times 3, right? So 3 is already part of that 6. So my LCD is 6 times m plus 1. And so that's what I want to make sure that I multiply each part by. So notice what I do here, right? So I'm going to take this and I'm going to multiply it by 6 times m plus 1. And this is all over 1. Do the same thing with this second part. 6 times m plus 1, all over 1. And then the last one, same thing, 6 times m plus 1. All right, and this is the part that I said we can kill off the denominators, right? Because we're multiplying each part by this LCD. So here I can see, just looking at these first two things here, that I'm multiplying by, that m plus 1 divides out, and then I'm just left here with 6 times -5m. Well, 6 times -5m is -30m. Okay, let's move to the second term here. So the m plus 1's divide out, and also I can see 3 divides into 3 once and into 6 twice. So I'm left with there plus 2m. And then on the last part, I can see that my m plus 1's divide out, and also my 6's divide out. So all I'm left with there is 56, so equals 56. All right, let's combine these like terms together. So -30m plus 2m is -28m equals 56. And then remember, I'm trying to solve, right? I'm trying to figure out what m is. So how can I get m by itself here? What do I need to do now?
Divide both sides by -28.
Yeah. And what is 56 divided by -28?
-2.
Yep, -2. All right, and then you want to double check to make sure that this -2 isn't going to make the bottom 0, right? Because if this answer makes the bottom 0, then it's not a good solution. We couldn't use it. But there's no problem here. If one of our factors was m plus 2, right, then this wouldn't be a good solution. But we don't have an m plus 2 in the denominator. So this is our answer. Okay. Oh,
So, question for this question?
yes, please.
So, can we multiply by like to use multiplication by 1, multiply by 6, n plus 1 over 6, n plus 1? So that's work or is going to make it difficult? So because sometimes I'm confused to multiply just the denominator and use cancellation method, or to multiply by LCD for both denominator and numerator.
So when you have like, oh gosh, I wish it wasn't up here so far. So on something like this, right, this isn't an equation. And so we have to have a common denominator in order to combine those together. So do you see on this one, we had to multiply the top and bottom by 5 to get us that common denominator, right? We weren't multiplying each part by the LCD. We were trying to get the denominators to both look like that. However, when it's an equation and you're solving, right, this is where we're saying, okay, let's multiply everything by the LCD, and then we can cancel out the terms that are in common and see what's left there. So that's the biggest difference is it an equation or not? So make sure you practice some more questions with some that are just saying to add and subtract and others that are telling you to solve. And just make sure that you have, like, there's more than one right way to do this, right? So if there's a way that you've liked that's worked for you on the homework that makes better sense to your brain, then use that way, okay? I'm more than happy to just have you work whichever way works best for your brain. Even if it's not the way I show you, that's okay. Okay, now this one is you're just solving for a certain letter, right? So here is the formula. They'll give you some kind of a formula, and then it's saying solve for this capital M on here. Well, right now that capital M is in the denominator, so trying to get it by itself is going to be hard. So we actually want to multiply both sides by that capital M plus M. And so, or some people, you know, think about it, since it's just one fraction equals another fraction, we can do that, you know, multiply this on the top here. But really what we're doing is we're multiplying this by capital M plus M, and this one by capital M plus M. All right, and again, these are over 1, so this is kind of hard to see. So this one I have mu, this is a Greek letter mu, so I'm going to rewrite it down here. So I have capital M plus M times mu, all right, and really it's, you're multiplying all of that there, equals, well, these divide out, and so then I'm just left with M times V. And now I can see, oh no, I've got these capital M's in 2 different places, so I need to get those capital M's together. All right, when I do that, I'm going to need to distribute this through to everybody. So I get M times mu plus lowercase m times mu. And these are so hard because all of these letters look so much alike, but this is an actual formula, so that's why they used it, right? But I want to get my capital M's on the same side, so I'm going to end up subtracting off this capital M mu to both sides. And so that's going to give me lowercase m times mu equals capital M times V minus capital M times mu. All right, and I'm running out of room there, so let me kind of go up here, right? So I'm going to write this down again. So, oops, V minus M mu. So can you see on this right side, capital M is a greatest common factor that can come out. So this side's going to stay the same. M times mu equals, let's factor out the capital M here, leaving us V minus mu. And then again, remember it said to solve for capital M. So to get capital M by itself here, it's connected by multiply and all of this. So now I can just divide both sides by V minus mu. And then I will be done. Whoops, oh my gosh. Mu is such a weird letter there. So my answer is capital M equals lowercase m times mu over V minus mu. And that's what I'd be left with. Okay. And hopefully, like on the test, they're not going to have like, I don't know. I mean, these are kind of crazy because all of those M's look so similar to each other. And I promise I won't do something like that on the exam. But it's still that same idea where you've got to solve for one of the letters. And a lot of times you have to use this factoring. I'm going to write this here, right? We factored out the capital M to get it together. It was in two different places. And so to get it together, we have to factor it out. And that's how we got just one capital M in the whole thing. Okay. Questions on that? All right. Couple more here, which kind of thinking maybe since we are kind of running low on time, I think what I'll do is I'll make another video about these story problems, the types of story problems that could show up on the test, and make one of those just separate for it. But let's do these last two problems where we're dividing polynomials to end this, because I'm sure you guys are your brains are getting full here. We've been working for like 2 hours and it just happens, okay? So let's look at this. So if we're dividing using long division, right? So we can use synthetic division when we have something like this, right? So notice that we have like our coefficient on our divisor is a 1. That's hard to write on there. But our exponent also is a 1. So that's how I know I can use synthetic division. This one, I've got an exponent of 2, so I can't use that synthetic division. I have to use long division. Okay, however, I see that in this x squared plus 2, there is a missing term, and I always need to make sure I'm putting in missing terms, and I'm writing it in descending order. So meaning it needs to start with the highest exponent, then the next highest, the next highest. So I'm going to rewrite it over here. So if I'm looking at the highest exponent is that x to the 4th. So I'm going to have 2x to the 4th. Then let's see if there's an x to the 3rd. Yep, so minus x to the 3rd. Then our next one would be x squared. Okay, we've got one there, minus 5x squared plus x, and then minus 6, right? So put that all in descending order. And then this one is missing a term. And if there was a term missing in here, meaning say that there wasn't this negative 5x squared, we'd have to put that in as a 0x squared. Right, so we can't have any missing terms. So if you have an x to the 4th, then we have to have an x to the 3rd, x squared, x, and then the constant term. All right, but here I can see, okay, I've got x squared. My x term is missing, so I'm going to put in plus 0x and then plus 2. All right, so this, what I'm dividing by, my divisor has to go on the outside. So I'm going to have x squared plus 0x plus 2, and that's going to divide into all of this stuff here that I put in descending order. So 2x to the 4th minus x to the 3rd minus 5x squared plus x minus 6. Okay, and then when you're doing this long division, you're kind of we're just looking at this first term and this first term. All right, so just kind of ignore the other parts to start off with. That's going to help us to know what we need to, how many times do we need to divide in. So we're thinking to ourselves, what times x gives me 2x to the 4th? All right, well, if I do 2x to the 2nd, right, 2x to the 2nd times x squared gives me 2x to the 4th. Right, that's what I'm looking for there. All right, and then I need to multiply this. I'm like distributing this through. So I'm multiplying this by all 3 of these terms. And this is usually where people make a mistake. That's why I'm writing these arrows here. So 2x squared times x squared is going to give me 2x to the 4th. Right, and then 2x squared times 0x is going to give me 0 x to the 3rd, right? 0 times anything is just 0, and then x times x squared is x to the 3rd. All right, now do this again. 2x squared times 2 is positive 4x squared. Okay, now at this point, this is where you would do your subtraction, but I like to just say change signs, because really, if I'm subtracting all of this, what I'm doing is I'm distributing a negative through to everybody. So I'm changing the signs. If they're positive, I change them to negative. If they're negative, I change them to positive. Okay, and so then what's left here? Well, that's gone, which is what I was trying to make happen, so that's good. Then here, negative x to the 3rd minus 0x to the 3rd is still negative x to the 3rd. Negative 5x squared minus 4x squared is negative 9x squared. And now I need to bring down the next term, so plus x. And then I'm going to start this over again. All right, so now I'm asking myself, what times x squared is going to give me negative x to the 3rd? So I'm going to have, okay, well, negative x. All right, so negative x times x squared is going to give me negative x to the 3rd, right, which is what I want it to be. And then again, remember, I'm taking that negative x and I'm multiplying each part by it. Sorry, it's kind of making a mess there, but I want to make sure it's clear you're distributing that through. Okay, so when I distribute that through, negative x squared, negative x times 0x is going to give me 0x squared, and then negative x times 2 is negative 2x. Okay. And now it's my subtraction part, but again, I'm changing the sign. So this becomes a positive, this becomes a negative, this becomes a positive. All right, and now combine those together. That's gone. Here I'm left with 9x squared. Here I combine those together and get 3x. And then bring down that last number there, that negative 6. And then we start it over again, right? So let's see, I'll do purple this time. So what times x squared gives me negative 9x squared? Well, that would be negative 9. And that's now what I need to distribute to everybody, right? Negative 9 times x squared is negative 9x squared. Negative 9 times this is just going to give me that x, 0x, and negative 9 times that is negative 18. And combine those together, but I've got to change the signs first. So right? And when I do that, I'm left with 3x, and then that's going to be plus 12, right? Negative 6 plus 18 is a positive 12. And there's nothing more to bring down, so that means this is the remainder. So to write my answer out, notice it says to write it in this form. Okay, so my answer is going to be 2x squared minus x minus 9. That's my quotient part. And then plus my remainder, 3x plus 12 on the top, and divided by that x squared plus 2. And if you put like that 0x in the middle there, you can. I'm not going to mark you wrong on that. If you do it like that on the homework, they probably would mark you wrong, but yeah. So that would be your answer on that one. Okay, last one. Let's look at this one when synthetic. And like I said, I will make a video about the story problems and stuff and post that separately, just because I kind of want to do a couple more than that is listed here, and that will give me that possibility to do that and not keep you guys on here so long. Okay, so with synthetic division, right, we're looking at this. It's just a different way to set it up, and it actually goes a little bit faster for us here. So we want to look at what we're dividing by here, this a plus 4, and we want to do what is the opposite there. Like, what's going to make this whole thing go to 0? Well, that's going to be negative 4. So I'm going to put this in this little box up here. And then I need to write down this, but I've got to make sure that there's no missing terms, kind of like I was doing up here on this other one. So I'm going to rewrite this down again. So this is a to the third, and there's no a squared term. So I need to put plus 0a squared. All right, then there's my a term, so minus 10a, and then plus 24. Okay, but when I'm writing this down in synthetic, we're not using any of the variables. Okay, so we're just using the coefficients here. So the coefficient on that first one is a 1. My second coefficient is a 0. Right, it's a little placeholder there I need. Then I have a negative 10, and then I have a 24. Okay, then I leave a space, above and below this line here, because that's where I'm going to be needing to put my work on my answer. So very first thing you do is bring down whatever that first number is. All right, so I just bring that 1 down. Then I'm going to take whatever's in my answer, and I'm going to multiply it by the number that is there in the box. So 1 times negative 4 is negative 4, and I put it underneath my next number. Then just combine these together like they are. 0 minus 4 is negative 4. Then do it again. Negative 4 times negative 4 is positive 16. Combine those together. That gives me 6. 6 times negative 4 is negative 24. 24 minus 24 is 0. So this last number here is my remainder, which means it divided in evenly, so I have nothing left here, right? But I can't just leave my answer as these numbers. I need to put my variables back in. And notice that my leading term, right, the degree of it was a 3, so then in my answer, it's going to be 1 less than that. So this is going to be 1a squared minus 4a, right? Just goes down 1 from there, minus 6, and then remainder 0. So if you have a remainder 0, you don't need to write out this part like that. You can just leave your answer like this. If you do put it as plus 0 over a plus 4, again, I won't mark that wrong for you, but it's not necessary. You can just leave it like that. Okay. All right, guys, I think let's stop there. And like I said, I will go through, make another video that is just going to be on the the story problems, and for some people that's, you know, they'll want to spend a little bit more time on that to make sure you have those down really well. So look for that video as well as this one, and yeah, remember you have all of spring break to get this done. You know, work on your homework. You can do the quizzes until March 11th. So that's the Monday we get back from spring break. So the homework and all of the quizzes and everything you can work on until then. Okay. All right. Any other questions before we go here? I know that was a lot. Thank you guys for being so patient and being such a good, and, you know, helping participate. It makes it a lot better. All right.
Thank you.
You're so welcome. Thank you guys. Have a wonderful spring break and have a wonderful weekend. Okay, reach out to me if you have more questions.